Right, in this video, we're still modeling with inequalities. This one's going to be non-linear, okay? You can see by the formula here, the function given to us, it's a quadratic, okay? We've got a v squared there. That makes this a quadratic, okay? Now, it looks like a quadratic equation, but when we read through the problem, we're going to realize, hopefully, that we need to set up an inequality here, okay? All right, so you will have gone through, by the time you watch this, you will have gone through solving those nonlinear inequalities and the process involved in that. Okay, so obviously you need to be comfortable with that before doing this, all right? So the gas mileage, which is measured in miles per gallon using the variable g here, for a particular vehicle, we don't know what it is, driven at v miles per hour, so the speed here is v, is given by the formula here. So miles per gallon, g, gas mileage equals 10 plus 0.9 times v, times that speed, minus 0.01 times that speed to the second power, okay? Now, this formula only works as long as the speed of the car that's being driven is between the speeds of 10 miles per hour and 75 miles per hour, okay? Now, within this range of 10 to 75 miles per hour, we want to find the range of speeds that maximize here the vehicle's mileage in terms of being at or above 30 miles per gallon, okay? So we want to be the most efficient we can, and we're trying to determine what speeds will make us achieve the best mileage here, okay? So a couple things we need to know here, all right? So this 30 miles per gallon or better for the mileage, we can write that in terms of a real basic inequality, okay? So G is going to be greater than or equal to 30. I know that, okay? Now that's going to help me. I'm actually going to use this and kind of plug this in here. Or you can look at it another way. I'm going to take this and I'm going to substitute this trinomial in for G. That's going to give me an inequality here that I can solve. So let's do that. Let's plug this trinomial in here for G. And what we end up with then is, and I've rewritten this in standard form, negative 0.01 v squared plus 0.9 v plus 10 has to be greater than or equal to 30, okay? Now I'm going to do a couple things here to kind of clean this up and make it nicer and neater for us. First thing, the first step in this process anyway is to get everything on one side. So I'm going to subtract 30 from both sides, okay? So I'm left with 0 on the right side, and 10 minus that 30 gave me this negative 20 here, okay? Well, I think I might be able to factor this, but it looks really ugly to factor it when it's written like this, okay? So what I'm going to do is I want to make this leading coefficient into 1, and I want to make it a positive 1, all right? So what I want to do is I'm going to multiply both sides of the inequality here times negative 100, okay? Now, the reason I'm doing that is going to give me a prettier quadratic trinomial on here that I might be able to factor. Otherwise, I'm going to have to use the quadratic formula to find what makes this 0. It's not impossible. It can be done. It's just I think this can be factored, and I'm going to convert it to a form that's more easily factored. Okay? So a negative 100 times this expression just gives me 1v squared. Okay? A negative 100 times 0.9v is negative 90v. A negative 100 times a negative 20 is a positive 2,000. Notice the inequality has to flip. I multiplied by a negative value. Don't forget that. That wouldn't make any sense here. If you were to go through this and this were reversed, the problem wouldn't make a whole lot of sense. And then on the right side, anything times 0 is going to be 0, okay? Again, if you don't realize how to factor this, that's fine. You can always use quadratic formula. You could have done that here. You could do that here. Doesn't matter, okay? But this can pretty easily be factored. Factors of 2,000 that combine to be negative 90 are going to be negative 40 and negative 50. So I can factor this pretty easily, v minus 40, v minus 50, okay? So that's going to help me determine what makes this 0, and it's going to help me determine my intervals, okay? So 40 miles per hour makes this factor 0, so that's going to be one of my values that are going to help me set my intervals. And then 50 makes this factor 0, okay? So we're going to use those two values to set up our test intervals, okay? Now, we got to realize here, we're not going to use negative infinity and positive infinity. One, because it doesn't make any sense. In the context of speed, there is no negative speed. And we're not going to go up to infinite miles per hour. That wouldn't make sense. in terms of the real world we live in, okay? But it does give us here that this formula only works between 10 and 75. So when I'm setting up my intervals, 10 is going to be my starting spot. Okay, 10 is going to be my low value, so I'm going to go from 10 up to my lower speed here, 40 miles per hour. My second interval will be between 40 and 50, and my third interval will be between 50 and 75, okay? If you put negative infinity to 40 and 50 to positive infinity, it's not a huge deal, okay? You always want to take the constraints of the problem and make sure they're part of your solution, okay? That you're using them in the process. All right, so we're going to use these two factors. So I need the sine of v minus 40, I need the sine of v minus 50, and then I need the sine of the product of those two factors from this inequality that we ended up with, okay? So as before, we want to choose values within the interval. So let's say 30 miles per hour here. So 30 minus 40 is going to be negative. Let's choose 45 here. So 45 minus 40 is positive. And let's choose like 60 here. 60 minus 40 is also positive, okay? Let's use 30 in this interval again. 30 minus 50 is negative. 45 minus 50 is negative. And 60 minus 50 will be positive, okay? So if I've got a negative factor times a negative factor, that's going to give me a positive factor. Notice from my inequality I ended up with, I needed to be less than 0 or negative here, okay? So 10 to 40 is not part of my solution set. The mileage here would not be over that 30 miles per gallon that we started with as our goal, okay? A positive times a negative gives me a negative. Well, that matches my inequality here, so that's going to be part of my solution set. And in the last interval, a positive times a positive is a positive. That doesn't work, okay? So now I've got the answer to my question, okay? So the question was, for what range of speeds is the vehicle's mileage 30 miles per gallon or better? Well, that's going to happen between 40 and 50 miles per hour, including both of those, because it says less than or equal to. Here, it said greater than or equal to 30 miles per gallon in the problem, okay? So that's how you use that solution process for nonlinear inequalities to model real-world situations.